So we're going to derive some representations of power series using our knowledge of the geometric series. So we know the function g of x equals 1 over 1 minus x is equal to the power series, the sum of x to the n running from 0 to infinity, for values of x between minus 1 and 1. And now we're going to use this to derive power series representation of other functions. In particular, the function we just mentioned, f of x equals 1 over 1 plus x to the 7, we can easily derive a power series representation for this using our knowledge of the geometric series. We're going to first start with a technique called substitution. So I know that 1 over 1 minus y equals 1 plus y squared plus y cubed, etc., etc., for y between minus 1 and 1. So 1 over 1 minus y is the sum of y to the n running from 0 to infinity, for values of y between minus 1 and 1. Now, I'm going to let y equal minus x to the 7. So now I know that 1 over 1 plus x to the 7 is 1 over 1 minus x to the 7. And substituting minus x to the 7 for y in the above formula, I get 1 over 1 minus x to the 7 is the sum from 0 to infinity of minus x to the 7 to the n for all values of x for which minus 1 is less than minus x to the 7, which is less than 1. And of course this tells me that 1 over 1 plus x to the 7 is the sum of minus 1 to the n times x to the 7n for values of x between minus 1 and 1. The inequalities minus 1 less than minus x to the 7, which is less than 1, become 1 greater than x to the 7, which is greater than minus 1 when I multiply across by a minus, and that becomes minus 1 less than x to the 7, which is less than 1 when I just turn them around the other way. So saying that minus 1 is less than minus x to the 7, which is less than 1, is the same as saying that x is between minus 1 and 1. This is actually the interval of convergence of this power series, the sum from minus 1 to the n times x to the 7n, since it's not difficult to see what happens at the endpoints of this interval from minus 1 to 1. When I plug in x equals 1 and x equals minus 1, I can see that this series diverges according to the divergence test, and it also diverges for values of x larger than 1.